Hello everyone, my name is Vito Faraci and I want to introduce my new calculator program called Calculator Plus Plus, or just Calc Plus Plus for short. Calc Plus Plus performs most functions as other scientific calculators. However, Calc Plus Plus has some additional capabilities that are not normally found in one package. Calc Plus Plus runs on your browser and does not require any additional downloads. This video was designed to introduce Calc Plus Plus and to serve as a short tutorial to get a user up and running with it very quickly. As shown on the screen is a list of some added capabilities that you may not find on the calculator you are currently using. Calc Plus Plus handles basic functions using complex numbers as well as real numbers. It has a built-in grapher and does some elementary calculus and much more. The definition of ln means large number. A large number is simply defined as any real number using a large number of decimal places. Most scientific calculators display numbers to only 15 or 16 decimal places, which is fine for many applications. However, there are some people, mostly mathematicians I suspect, who would like to view the results of their calculations to a very large number of decimal places. So in addition to the previously listed capabilities, Calc Plus Plus handles most all basic math operations to a user-defined number of decimal places or digits. For example, pi to 100 decimal places would be expressed as shown on the screen, as shown here. Note, this program was designed for a PC and not a supercomputer. As with all calculation programs, there will be a time requirement, maybe several milliseconds, seconds, minutes, or even hours, to calculate solutions to various expressions depending on the number of digits or decimal places required and the speed of your computer. All right, here's a picture of a main screen of Calc Plus Plus. Note the screen is made up of 4 sections: an expression input section, a constant entry section, and a graphing control section, and also the graphing area itself. You have to scroll down to see the graphing area, the full view of this graphing area anyway. Okay, the graph shown is the sign of x in blue, the sign of 2x in red, and the sign of 3x in green. Take note of the y-axis and x-axis limits. Y-axis limits are from -1 to 1. The x-axis limits are from 0 to 2 pi. Note also, the first 3 sections have help buttons. Okay, expression help, constants help, and graph help. Okay, click on the expressions list and help button, and you will see a list of all the functions, or a partial list anyway, of all the functions that Calc Plus Plus can handle. Type expressions into any one or all 3 expression boxes and the results will appear automatically in their respective outboxes. All three expressions are independent of each other. Calc++ handles ordinary addition, subtraction, multiplication, division, exponentiation, and trig functions of both real and complex numbers. Here are some samples shown on the screen. The division of complex numbers, exponentiation of complex numbers, and a trig function of a complex number. In the constant entry box, type a letter, upper or lowercase, and set it equal to a select value, and then hit enter on your keyboard. The constant will now appear in the constant's memory box. Now all expressions, functions, and also access limits can use any or all of the constants shown in the memory box. Constants can be in the form of real and complex numbers, or as constant functions as shown on the screen. When using constants, be aware that the letter E, both upper and lowercase, and letters P and I, both upper and lowercase, are reserved constants. Okay, I'm going to change the value of A, and notice what happens. I'm going to say small a equal 2. And I'm going to hit enter on my keyboard. Notice the value of A changes in the memory box, and now I'm going to plot the graph. Notice sign of 2x now appears. Before it was sign of 4x. Let's show that again. A equal 4, enter. Okay, A is now 4. Graph, plot graph, and here it is. Here's a graph of sine of 4x. From 0 to 2 pi. Okay, so constants can even be used in the on the graph limits, the axis limits. Okay, check that out. Now, also, as far as constant functions, take a look at this. Capital S, I assigned it as 4 times the sine of pi over 2. So if we want to know the value of capital S, just to show you that the capital S now is equal to 4, and can be used in any other expressions that you may want to calculate. Small a, let's look at small a. Small a is a 4. Big A, notice big A is now, I set it equal to mod 16 mod 7. Let's look at capital B. Well, B equals 7 over 2, which is 3.5. So you get the idea. To display graphs, enter a function and/or expression using small x as the variable in any one or all 3 expression boxes, and then hit Plot Graphs button. The user-defined constants can also be used for graphing. Note on the screen for this example, x min is 0, x max is 2 pi, which is equivalent to 2 pi radians. Y min equals minus 1.2 and y max plus 1.2. As a result, let's see what we get. Okay, if you look at your graph, you notice one cycle of sine of 1x colored in blue, two cycles of sine 2x in red, and the sine of 2x plus cosine 3x over 4 in green. To demonstrate the Calc++ graphic derivative and integral capabilities, the simple function f of x equals x squared is used, which is typed into the top input expression box with both checkboxes checked, as shown on the screen. Right, here are the checkboxes, and here is x squared up here. You recall from elementary calculus that the derivative of x squared is the straight line function f prime of x equals 2x, and the integral or antiderivative is a family of curves equal to capital F of x equal x cubed divided by 3 plus some arbitrary constant labeled here as f naught. In this example, f naught is set to -9, which is the initial value of the integral f of x at x equal x min. Since x min is -3 in this example, f naught is equal to x min raised to the 3 power, or x min cubed, all divided by 3. Notice in the upper right-hand corner of the graph is a color code for each of the 3 graphs. Blue for the initial expression, which is in this case x squared, and red for the derivative. The graph of the derivative is red, and green for the integral. Calc++ is actually 2 different types of calculators in one package. All calculations made on this screen were limited to 16 decimal place accuracy, like most other scientific calculators. Now let's take a look at the large number calculator, or LN calculator for short, which does not have that limitation. Click on the button called Go to Large Number Calculator, as shown on the screen, and now you see the large number calculator screen, which it's named LN calculator for short, which does not have that limitation. Note there are 22 functions listed on this screen. As far as LN calculator is concerned, the definition of large number is any real number containing a large number of digits, and not necessarily a large in value. Here is a multiplication example of 2 large numbers a and b. Note a 3 is entered in the function number box as shown on the screen. The number 3 represents multiplication as shown in the list of functions box, and some large numbers in the a equal and b equal input boxes. Note that a and b in this example are not large in value, but they both contain a lot of digits. Now hit the Solve button and notice what happens. Notice the problem is restated in the outputs box. Here's the problem restated. Here's A times B equals, and here's the product. By the way, the ET means elapsed time, which is the time taken for this calculation. All right, now let's take a look at a division example of 1 divided by 700. Notice a 4 is entered into the function select box here, as shown on the screen. And division A over B is shown in the function selected box, shown on the screen. Also note a 10 is entered into the digits box. Hit solve button, hit the solve button, and notice the quotient in the output box shows 10 decimal places. Okay, we can count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, now enter 100 in the digits box. And same problem, but now 100 decimal places are shown. Let's try 1,000 digits. So here we have 1 divided by 700 evaluated to 1,000 decimal places. Okay, now try entering in the digits box an R, or capital R, small r or capital R. Okay, and solve and see what you get. Notice, look here, 1 divided by 700 equals 0.00142857 R6. The R6 means the last 4 digits, the last 6 digits on the right side of the decimal point repeat forever. Also note, you can clear the output box, okay, and hit solve, and to clean up the output box for a little more clarity if necessary. And oh, by the way, you can also cut and paste this expression. You can cut and paste into another, like a Word document or an Excel spreadsheet or a notepad, whatever. This Calc++ program is made up of close to 2,500 lines of code, so I will be highly surprised if it's bug-free. Please email me any questions, comments, or bugs that you may find to my email address shown on the screen. Here it is. Also, if you have a request for a math problem that can be solved by a calculator that is not already covered by Calc++, send the request to me and I will consider adding it to Calc++. To run and operate Calc++, just open your browser and type in the URL that you see on the screen. Here it is. There is nothing to download. Good luck with it.